happiness is the truth. Because I'm happy. Clap along if you know what happiness is to you. Because I'm happy. Clap along if you feel like that's what you want to do. Here come bad news, talking this and that. Well, give me all you got, don't hold it back. Well, I should probably warn you, I'll be just fine. No offense to you, don't waste your time. Here's why. Because I'm happy. Clap along if you feel like a room without a roof. Because I'm happy. Clap along if you feel like happiness is the truth. Because I'm happy. Clap along if you know what happiness is to you. Because I'm happy. Clap along if you feel like that's what you want to do. Hey, bring me down, can't nothing bring me down. Love is too high, bring me down, can't nothing bring me down. I said, now, bring me down, can't nothing bring me down. Love is too high, bring me down, can't nothing bring me down. I said, cause I'm happy. Clap along if you feel like a room without a roof. Because I'm happy. Clap along if you feel like happiness is the truth. Because I'm happy. Clap along if you know what happiness is to you. Because I'm happy. Clap along if you feel like that's what you want to do. Because I'm happy. Clap along if you feel like a room without a roof. Because I'm happy. Clap along if you feel like happiness is the truth. Because I'm happy. Clap along if you know what happiness is to you. Because I'm happy. Clap along if you feel like that's what you want. Good afternoon, everybody. You can probably tell I'm going to pop back and forth between my two stations. Laura, can you give me a thumbs up if you can hear me, please? Perfect. So, you guys, we did really well on our check for understanding that was due last night. So well, in fact, that I don't think we'll spend any class time going through it. However, if you want to take a look at, your own mark that was released and you feel like you want to go through it with me, just let me know and we'll set up our own little private meet and we can go through that check for understanding. For now, our job today is to get into some chord properties. So we're going to go through lesson 4, part 1, and then you're going to have a bunch of work time. So really just lesson 4 today, instruction and practice work. And here we go. There we go. So guys, I want you to start off here just by reading the properties on page 393, and then we'll regroup and try to kind of wrap our heads around what it is that you are reading. So go ahead to page 393, please. So it probably sounds complicated, and it does talk about 3 properties, and yet all of those properties do seem to kind of be saying the same thing. So when we talk about the chord properties, we're actually going to talk about them as if they are a little bundle of properties. So it's kind of like there's these 3 different situations that all go hand in hand. So kind of in any order. So the first one, it says, if a line through the center is perpendicular to a chord, then the chord is bisected. So I want to just sort of highlight the 3 pieces for you. So line through the center, perpendicular to the chord. Chord is bisected. So there's these 3 pieces, and the idea is if 2 of those pieces are present, we can conclude that the third one is also present, and it doesn't matter the order. So you'll notice in this one, it's given in a different order. It talks about if a line is perpendicular bisector of a chord, then the line is going through the center. And then the third one, still talking about the same 3 properties, just in a different order. So any line that goes from the midpoint of a line segment to the center is perpendicular to the chord. So it's almost like we just keep saying these same things over and over. Now let's first of all make sure we understand what these words are actually talking about. We know perpendicular means that they make a right angle. Charlie B, is there something you need to tell us?
Yeah, Ty low-key kind of just got kidnapped, just a bit.
Ty Loki. Did I hear you right?
I was watching the thing, and then Ty kind of just low-key got taken away, so.
What am I missing here, Charlie? I feel like I've told something's way over my head here. Who's Ty Loki?
Oh, Ty Jensen, but like, no, Loki's just a weird.
Loki just got kidnapped. Oh, okay. Now I get it. When I look at it typed, now I get it. And so Ty, just checking in, you're okay? So we're all set? We're all ready to go on? Thanks, Charlie, for, alerting us to possible kidnapping. If it does happen, of course, a kidnapping is more important than a math property. So, of course, yes, do interrupt the lesson if somebody is kidnapped. Okay, well, moving on. Let's make sure we know what all these words are talking about. So when we say that something is bisected, so a line segment, an angle, a circle, any geometric object can be bisected, which means it gets cut into 2 equal parts. And midpoint is actually just another way of sort of describing a bisector. So if this point is right in the middle of a line segment, it means that it cuts it into two equal parts. So that midpoint would be the point that is bisecting the line segment. Now I know we're kind of at the point where everything still seems like gobbledygook. So let's take a look really at like what does this property really tell us. So in this first column, we're looking at given information. And then we're going to talk about what can we add to it? What can we conclude? So what we see given to us here, see how this point is highlighted right there? That's the center point. And so we've got a line coming from the center that is perpendicular to the chord. So what we're given is line from the center and we see that it is perpendicular to the chord. So that's two pieces. So we can add on or conclude the third piece, which is the chord is bisected. So it's like these three pieces always go hand in hand. Now, number two, what it's showing us is this line segment. Notice we're not shown a center point. It's just this random line segment, but it makes a perpendicular or makes a right angle with the chord. So we see that the lines are perpendicular. We also see that the chord is bisected. So those are the two pieces that are shown to us. The piece that we can add on, that third piece, is that this line must be going through the center. Okay, and then in number three, again, now we're back to that point being highlighted. So we see that there's a line coming through the center. And we see that the chord is bisected. I want you guys to just think about what is that third piece? What's the third piece to this little bundle that we can conclude to also be true? So we've got the line through the center, the chord is bisected. The missing piece is that they are perpendicular. Or you can even just say they make a 90-degree angle, so we can add on that third piece that they meet at a right angle. And still, I know these three pieces it still can be a little bit confusing. So in the oval here, what we have is another one of our good habits. So Friday, we were talking about the good habits when you're working on a circle diagram. So the good habit here is when we see two pieces from the property are present, we should mark the third one on the diagram as well. So the two pieces that I see, so they named this point here, so this must be a line coming from the center. The chord is bisected. So everybody think about what is the third piece? What is the piece that we can conclude? And who wants to tell me that third piece? Nobody's jumping on this one. So let's look back here. Let's look back at the three pieces. So what we have been given is kind of like what we see in number 3 here. We know that there's a line coming from the center. We know that there's a chord that's being cut into 2 equal parts. The final piece that we can add on ourselves is that the chord and that line coming from the center make a right angle. So we're going to draw the right angle right on there. And, you know, really, we do that even before we look at, like, what are we really supposed to be finding here? So we're supposed to be finding angles X, Y, and Z. And you know what? We've already found X. X is equal to 90 degrees. Now I'm going to pull out this blue triangle just so that you don't have a bunch of extra information there. 90, 30, and angle Y. I need somebody to tell me the measure of angle Y, please. And you can just turn your microphone on and give us your answer. Ava H., how about you? Can you tell us the size of angle Y?
60 degrees.
And how did you find that out, Ava?
Thanks. 90 plus 30 is 120, and 120 plus 60 is 180.
All right, so she's using the idea about how the 3 angles in the triangle add up to 180. So she's doing 180. She added up the 90 and the 30 and said that was 120. And that gave her the 60 degrees. Perfect. Now, angle Z, I want you guys just to use your common sense here and see if anybody can tell me angle Z. Just kind of doing what comes naturally, what you would almost make an assumption about. Any volunteers for angle Z? Bailey, what about you? What does your gut tell you for angle Z?
That it's 30 degrees.
Perfect. Now, I want to know, Bailey, was that totally just your kind of your gut, your instinct, or do you know a rule to explain why it's 30 degrees?
Because like A and C and B are the same length, and the angles both reach up to the same point, it makes sense that they would both be 30 degrees.
Okay, gotcha. So it just kind of made sense to you. You're looking at this line segment and this line segment, which are the same length, and then you're reaching up to the same point, and it just made sense that those would have to be at the same angle. You know what you're describing there is actually an isosceles triangle. So you probably remember from years gone by that an isosceles triangle has 2 equal sides. So if you look in here, that is an isosceles triangle because this is a radius and this is a radius. And we know that the 2 radii definitely will be the same length. So if I was just to draw out that triangle, AOB, I know that it's an isosceles because those 2 sides are the same. And maybe what you don't realize, or maybe you've never heard it, or maybe you even forget it, but on an isosceles triangle, the base angles are always equal. So if this one's 30, then this one is also 30 degrees. So let's write that one down. That one's going to come into play more in the future. isosceles triangles, 2 equal sides, and 2 equal angles. But for some reason in isosceles triangle, we always just sort of think about the sides, but the angles are true as well. And it is kind of like what Bailey said. You know, if they're reaching up to the same point, they'd have to be going at the same angle. Guys, any questions for that first example? Okay, example 2. So O is the center of the circle. So what we see is, I see a line coming from the center. I see it makes a right angle with this chord. The third piece that I can add on here is I know that those 2 segments will be the same length. And it says, find the length of chord AB. So I'm just going to pull that little right triangle out of there just to make it look less complicated. And I want you guys to go ahead and find the length of chord AB. So we'll give you about a minute to figure it out. All right, so check your work with mine. I did my Pythagorean theorem here, and I found that the side that I called x is equal to 8. So if I go and I put that back on my diagram, the question was actually about chord AB. So chord AB is the distance from here all the way to there. And so really all I have to do is multiply by 2 to get AB is equal to 16 centimeters. All right, we're going to pause just for a moment here, guys. I want you to look at page 20 in your booklet. I want you to go ahead and answer A, B, and C for number 1. And I'll be asking people for answers. These first 3 are really just there to make sure we understand what the chord property is. All right, guys, let's look at A. And Holly, I'm going to get your help here. First of all, let's look at what we do know. We know that we've got this line coming from the center. We know that it bisects the chord. So Holly, how big is angle D?
90 degrees.
Perfect. Okay, let's go to B. In B, what we see is that there is a line coming from the center, and it is perpendicular to the chord. So, Caden, what do we know about that line segment E? How long would that be?
7.
Yep, also 7. Good job. And then for C, here's what we know. We know we've got a line from center that is bisecting this chord into 2 equal parts. So, Darielle, tell me the length of F. Let's try Maddie. Maddie, what's the length of F?
Would it be 9?
Yeah, it is 9. And that one's really just checking to see, do you know what those little tick marks mean? So the whole chord, since that 18 is right at the center of the chord, it means it's the length of the entire chord. And that would come from 9 plus 9. All right, so we have a feel just for the general property of a chord. Let's take a look at some questions that are going to take some of those good habits in. So we've talked about last week how lots of our work is going to deal with right triangles. As soon as we have a right triangle, there's so much that we can do with it. We know the 3 angles add up to 180. We can do Pythagorean theorem to find missing sides. So anytime you get to a circle diagram like this and there isn't a right triangle there, you're probably going to need to make a right triangle. Otherwise, you get kind of that feeling of it's a dead end. Like there's nothing there that I can really work with until I get a right triangle going. We're going to go ahead and read the directions on this one. And in the blue oval here, it says, first, label the diagram with everything you know about it. So as we read, we're going to label our diagram. It says, AB is a diameter with length 26. Now, I think the easiest way to write that on is to actually label the radii, 13 for each radii. And CD is a chord that is 10 centimeters from the center O. So this distance from the center O to the chord is 10. And then the question, what is the length of the chord? So here's one of those good habits that we had on our list last week. All radii in the same circle are equal. Try drawing on another radius. So what we want to do here is we want to make a right triangle by drawing on another radius. So I'm going to add a radius right here. I know that it's 13 units long. I also know our chord property. I know that this line from the center that makes a right angle with this chord, it also bisects the chord. So I also know that those 2 segments would be the same. Okay, so I'm going to leave it up to you guys. What is the length of the chord? And the chord we're referring to is CD. Okay, everybody, you got about a minute to figure out the length of CD. So it turns out this question is really exactly the same calculation that we did here. So we're using Pythagorean theorem to figure out half of the chord and then multiplying by 2 to get the whole chord. What I want to show you on this guy here is that we're not going to round off our answer until our we're not going to do any rounding unless it's our final answer. So I'll show you what I mean with my calculator. So I'm going to do my Pythagorean work. So square root of 13 squared, subtract 10 squared, which by the way is just 100. You don't have to put 10 squared. Now when I hit enter, I see, oh, it's one of those decimals that goes forever and ever and ever, and I do not want to round it off because it's not my final answer. So what I'm going to do, I'm going to write it here. It came out to be 8.306. I'm just going to go dot, dot, dot so that we know I haven't rounded it off. All the decimal places are still there. And to get to my final answer, I have to multiply that by 2. So I'm leaving that whole number right on my calculator screen. And I'm just going to hit times 2. And then this is my final answer. This is the one that I'm going to round off. So I didn't round that number off yet. I'm going to say that CD is equal to 2 times 8.306 and on. And that my final answer, do we have a rounding instruction? Oh, darn, I didn't give rounding instructions. I'm going to give those rounding instructions now. Let's go nearest tenth. So I'm always at that part where, okay, I got to write my answer. This is where I look for those rounding instructions. So 16.6. And I also kind of look back and see where they're units. And it's, oh yeah, up here it says this is in centimeters. So make sure you include units in your answer. So I know your calculator is going to look different, but your keystrokes and your process there are going to be the same. Guys, any questions about that one? Now remember, if we hadn't drawn on that radius, we wouldn't have had a right triangle, and that one would have just been basically a dead end. So that's a good rule to remember. Make a right triangle if there isn't one. Okay, and example 4 is a little bit of a word problem now. Rather than just here's a circle, now we get to see an application situation. So we've got this horizontal pipe. So guys, this horizontal pipe has a circular cross section. So that's what we're looking at in the diagram they gave us, is the cross section. So it's like if you were looking into the pipe, this is what you would see. It has the center O. Its radius is 22, so let's put on the 22 for our radius. Water fills less than 1/2 of the pipe. The surface of the water, AB, so the blue section on my screen here is the water, and it is 40 centimeters wide. Now, here's a little bit you might feel like, oh, are we just assuming that this is all working out? But the water sitting in there still is definitely going to mean that this is a perfectly horizontal line. And we're going to say, okay, I want this line to be completely vertical. And this line that's coming from center would then be, whoops, that's not going to show up. It would be bisecting this chord. So that 40 centimeters is going to be split up between 20 here and 20 there. And our job is to determine the maximum depth of the water, CD. So from C to D, that's the deepest part of the water. So in other words, I wouldn't measure the deepness here because that wouldn't be at the maximum depth. So that word maximum might throw us off. You might be thinking, oh, I want to see how much water could actually fill this pipe. But that's why they've told us it's CD, just to clear up any confusion. We're trying to just see how deep the water is at its deepest point. All right, well, sometimes you just have that feeling of I don't really know where to start, but let's start by writing on our third piece here. We've got the bisector, we've got the line through center, so I know that's a right angle. And this might be one of those ones where we say, I don't really know where to start, but what can I find? So I know that if I pull that triangle out, the 22, the 20, I know that I can figure out this side right here, which I'm just going to call X. And I want you guys to go ahead and find that side. It is not our final answer, so don't round it off. A little Pythagorean work. And again, it's an irrational number that goes on forever. So a little dot, dot, dot to say I haven't rounded that number off. But we also need to now know, like, what am I doing with that number? What I have found is that this little section in here is 9.1651. So how is that going to help us to figure out CD? So I want everybody to think about this really carefully. I need to figure out the length from C to D. And I'm wondering if anybody knows the next step. Please volunteer if you do know. Charlie, what do you think? Charlie B?
Since the radius is always the same, we subtract it, like what we have, to what's left.
Yeah, that's exactly right. See how this radius is 22? Well, OD is also a radius. And I'm kind of impressed that you saw that, because you know what? A lot of people don't see it, Charlie. They know, oh, there's 22 here, and they, for some reason, don't realize that that is also 22. So good job on figuring that out. So to get CD, we're going to do 22, subtract the 9.1651. So on your calculator, you're going to do 22, subtract your last answer. That way you haven't rounded anything off until right now when you write your final answer, which will be 9.2. We're going to stick with the nearest tenth again. And units are centimeters. Okay, and guys, can I see thumbs up for that one? Everybody doing okay there? And keep your thumbs up if you noticed, if you knew that that was a radius there. Hey, that's pretty good, you guys, because sometimes
Wouldn't the 22 minus like the 9 not be 9?
Oh, yeah, that answer doesn't make sense. 12.8. That makes more sense, doesn't it? Oh, dear. You should be making sure your answers make sense when you write them down, Mrs. Booth. Thank you, Ava. All right, so guys, we're ready to do some practice work. Your assignment is going to be pages 20 to 22. But before we get to it, I want you to make sure you've updated your properties sheet. So this is the way that I put it on my property sheet. I kind of started by saying that, first of all, what is it? It's the Chord property, and I said there's actually 3 properties. But then I wrote them down as kind of those 3 pieces that work together in the bundle. And then in my diagram, I just labeled them all. I labeled or highlighted the center point. I put the right angle on. I put the 2 equal segments on. And remember, as long as 2 of those pieces are present, we can automatically put the 3rd piece on there. So we're staying together in the meet here for at least 20 minutes. You guys can go ahead and get started. Please ask questions whenever you're stuck. And after 20 minutes, I've got a little information to share with you, and then you'll be allowed to leave the meeting if everything is going smoothly. Any questions? Alrighty, use that time well, guys, but don't be afraid to ask questions. In a little bit, I'll expose a few answers for you just so that you know that you're on track. So try to work at a pretty good pace. I want you to have attempted the question before I show the answers. Hey guys, the page numbers are 20 to 22. And just checking on making sure I haven't messed up attendance. Darielle, if you're there, would you send me a quick chat, please? Let me know you're here. I
Ty, are the kidnappers back, or are you okay?
they keep messing with me.
I wish I was there to help you. I'd kick him in the kneecaps or something, but can't.
I
help
know,
it.
Brenda.
The kidnappers, man. Yeah, yeah. I just